Hi, this video is going to look now at how alpha, beta and gamma decay occur. In alpha decay we have the nucleus here, the unstable nucleus. Now this is called the parent nucleus, or sometimes it's called the parent nuclide. I guess parents have children, and this is called the daughter nuclide. Now I just introduce you to that word or these terms here because we are going to use them more and more as we go forward and we start looking at half-life. But for the moment we're just going to think about this as being the unstable nucleus, and then it breaks down to become slightly more stable. If you remember, that was due to the imbalance, the too many protons or too many neutrons in the nucleus. And what's given off then is 2 protons and 2 neutrons, and they're clumped together. Now 2 protons and 2 neutrons, you'll remember, gives you 4 nucleons and 2 protons. If you recall from the periodic table, helium has 4 nucleons and 2 protons. Just remind you of that there. If we have a look closely here, 2 protons, 4 nucleons. So actually, alpha radiation is a helium atom, except it's a helium atom without the electrons going around the outside. So actually, alpha is a helium nucleus. So you'll sometimes see it written as helium. You'll sometimes see it written as alpha, and occasionally you'll see it written with the same numbers, 4 and 2, but written as alpha. It is the same thing. So let's just review that. An unstable atom, because it's got too many protons or too many neutrons, when it decays it gives off a smaller atom that's more stable called the daughter, and also it gets rid of some of that instability by firing off a big heavy helium nucleus, sometimes called an alpha particle. Let's look at beta decay. Now beta decay, if you remember the symbol for beta, is actually very, very similar, except the thing that's given off is a lot smaller. In this example we've got again the parent nuclide on the left hand side. I'm just going to write parent this time rather than writing out nuclide, and it breaks down to make a smaller, more stable daughter. But it also fires off here an electron. Now how on earth could we have an electron? Well, actually what's going on inside here is quite strange. If we just look at this bit here, what do you notice happened? We've actually turned a neutron that's neutral charge, and it's turned into a positively charged proton and released a negatively charged electron. So if we just think about that for a moment, positive, negative, that gives us no charge. So they balance out. But how can a neutron make a proton and an electron? Because if you remember from the stuff you've learned in chemistry, you'll know that the mass of a neutron and the mass of a proton is 1. Actually it's not. The mass of a neutron is fractionally slightly larger than the mass of a proton. So when it breaks down from the neutron into the proton, there's a tiny little bit of mass left over, which allows an electron to be made. So let's just really quickly make sure we remember this one now. Unstable nucleus breaks down to make a more stable daughter nucleus and fires off, like a bullet, a fast electron. So beta decay, the beta particle is an electron. Very, very small, very, very fast. And the last part then is gamma radiation. Now gamma radiation, if you remember, is not a particle. It is part of the electromagnetic spectrum. Exactly the same thing happens. A parent nuclide breaks down to make a daughter nuclide. But there's one thing about gamma radiation here. Gamma radiation cannot occur on its own. It must occur, in this example, with alpha radiation, but it could have occurred in the previous example with beta radiation. So it cannot occur alone. So in this case, it's radiation which is a wave. So remember, alpha, beta are particles and gamma is a wave.